5.5. 29? Are there many? Oh my
Yeah,
God,
that's
I
what
didn't
we
know. Okay. 29, where are you? 20, 21, 23, 26, 28, 29. I got it. We have the integral from 0 to 1 over 8 from sine inverse 4x over the square root of 1 minus 16x squared dx. And as I said several times, when you get to my age, you start checking your memory. I want to see if we did this problem last time because it rings a bell, but I could be wrong. And if I am, I apologize. Because I remember this one, but maybe not. Maybe not last time, maybe the time before. Yes!
Okay. Yeah, I'll rewatch the video.
It's exactly the same, except you have 1 over 8 instead of 1 over 2. Very good. Next question. I don't mind doing it again if that's what you want. I'm not. It's up to you.
Oh, it's fine. I can just rewatch the video. Can we do a problem? The net change, distance traveled.
Yes. Yes. Do you have one for us?
No, I don't.
Oh, okay. So let me get the book. The entire house is shaking when I put this on the table. Okay, so we want a distance. Yes, I found one. And you tell me whether this is what you had in mind. So we are given v of t equals t squared minus 2t minus 8 on the interval 1 comma 6. And if I'm given the acceleration, then I have to find the velocity first, and the same steps are applied. It says find the displacement and the distance traveled by the particle during the given time. So okay, so for the displacement displacement means, so the particle starts here, it does whatever, and it stops here. This is the displacement. Starting point till ending point. So the total distance is something else. Starts here, I'm adding this, I'm adding this, I'm adding this, I'm adding this, I'm adding this till this point. Okay, so this is the displacement and this is the total distance. Okay, so let's start with the displacement. Equals the integral from 1 to 6 from t squared minus 2t minus 8 dt. So this is t to the third over 3. Oh, I'm sorry. Is this what you had in mind?
Yeah.
Okay. So minus 2 t squared over 2 minus 8t from 1 to 6. I plug in 6. Minus 1/3 minus 1 minus 8. So I can divide that, so the fraction goes away. 6 to the third and I divide by 3, and that's 72, minus, this is 84, minus 1/3, and this is 9, but with minus in front, so positive 9. So 72 minus 84, that would be negative 12, plus 9 minus 1/3, so this is negative 3, and minus 1/3, negative 10/3. Which means that the particle started here and ended somewhere here. Okay, and now let's see the total distance. The total distance is a totally different situation. Is the integral from 1 to 6 from the absolute value of the velocity dt. So this is the integral from 1 to 6 from t squared minus 2t minus 8 in absolute value dt. That's the reason why we studied absolute value so much, because we need to present this expression without absolute value. So there are two options. If t squared minus 2t minus 8 is greater than or equal to 0. And the other option is negative t squared plus 2t plus 8 if the same quantity, t squared minus 2t minus 8, is less than 0. So now I have to solve this inequality and then break up the integral into two integrals, of course. One from this and one from this. But I have to solve the inequality because I don't know where it breaks. So t squared minus 2t minus 8 greater than or equal to 0. We factor into t minus 4 and t plus 2. You can graph this to see the sign, or what I like to present is that table in which I study the sign of each factor, and then I get the sign of the product, t minus 4, t plus 2, from negative infinity to infinity. Obviously, this is 0 at negative 2, and this is 0 at 4. The numbers have to be in ascending order. 0 here, and the sign is negative and positive. 0 here, the sign is negative and positive. How do I know? These are linear functions with a positive slope. They have to come from negative and go to positive. The slope is positive. If the slope were negative, they would have been reversed. But that's not the case. 0 here, 0 here. Obviously, when I multiply two negatives, I get a positive. When I multiply a negative and a positive, and when I multiply two positives. So this inequality has this solution. So negative infinity, negative 2, union 4 to infinity. I always refuse to solve the second inequality, because what's not here is here. So this is negative 2 less than or equal to t less than or equal to 4. Don't waste your time with the second inequality. Okay, so only now I know how to break this integral up. Since we're talking about 1 through 6, I will have an integral from 1 to 4 and an integral from 4 to 6. Here's 1 and here's 6. From 1 to 4 and from 4 to 6. So that's page 7 for me. Okay. So the integral, so I'll write it again, total distance. 1 through 4 and 4 to 6. Okay. 1 through 4 is here from this function. Four to 6 is here because that's where 4 to 6 is from this function. So t squared minus 2t minus 8. This was more involving because it was a quadratic function that we were looking at. It was not a linear function. Okay, so negative t to the third over 3 plus 2t squared over 2 and plus 8t from 1 to 4, and plus t cubed over 3 minus 2t squared over 2 minus 8t from 4 to 6. This is a property of the definite integral. We can break it up like that. Okay, so the next step, I have to plug in. I don't think that this is too visible. Okay, so when I plug in 4, 64 over 3 plus 16 plus 32 minus, careful now, negative 1/3 plus 1 plus 8 plus, I plug in 6. I think we just got that, right? 6 to the 3rd over 3 was 72, wasn't it? Yeah. So I'm just going to write 72 already. Okay. Minus 36 minus 48 minus, now I plug in 4. 64 over 3, sorry about that. Ashley, I'm in class, I'll call you back. Thank you, sorry, bye. So where am I? I'm plugging in 4. So 64 over 3 minus 16 minus 32. Okay, I'm checking so I'm on the right track. 36, 48 minus 64 minus 16 minus 32. Okay. Of course, this has to be a positive number. There is no discussion there. Because we are adding, no matter what the particle does, we're always adding. We're not subtracting anything. Okay. So negative 64 over 3. And this is plus, it is 48. Ah! Okay. So 48 with negative 48 will go away. And then I need it out of here. And then I have 72 minus 36, which is 36. So these are done. This is done. This is positive 1/3. And this is positive 9, but minus 9. And this is minus 64 over 3. And this is again negative 48, but positive 48. Okay. So 48 and 36, 84. Check my numbers, please. Don't let me make an error. So 36, yes, I think that that's correct. Yes. And then 128 plus 1, negative 127 over 3. So I took care of these. And I forgot minus 9. Okay. So that is 75, is it? Minus 127 over 3. So I multiply this by 3. So 75 times 3, but minus 127. And that's 98 over 3. And that is the total distance. You understand that when we calculate an integral from a positive function, the answer has to be positive.
Okay. Can I see the sign chart again?
Yes, of course. I recommend the sign chart anytime, especially when you have a higher degree. If you have only quadratic, you can say, well, I know it has a minimum. It crosses at a negative 2 and 4, so obviously it's negative between the solutions and it's positive outside. You could avoid this. But when you have a ratio and more factors, like 3 or more factors, I would definitely use the table.
If it were 3 factors,
yes.
would it be 3 integrals? With 3 sign changes or 2 sign changes?
So you mean to study the sign?
Yes.
Okay, let me show an example with studying the sign. Assuming the problem or the expression is already factored. So let's say negative 2x plus 1, x, 3x plus 6, and x minus 4. Let's say less than or equal to 0. It's already factored, so it's really helpful that it's factored. Otherwise, I have to work hard to factor it. The first factor is x. This is the variable in the problem, not the factor. So this is the factor, and this is the variable in the problem that goes anywhere. Okay, so this is the first factor. This is the next factor. This is the next factor. X minus 4. And of course, I don't have enough room, so I'm just going to write the word product. By product, I mean the whole thing, because I don't have room in there. And now I have to put the x values for each one that makes it 0. So this one will have a 0 at 0. This one will be at 1/2. This one will be at -2, and this one will be at 4. If you set this equal to 0, you get 0. If you set this equal to 0, you get 1/2. If you set this equal to 0, you get -2. If you set this equal to 0, you get 4. These are the numbers that I have to put in the correct order. -2, 0, 1/2, and 4. 0 under 0, 0 under 1/2, 0 under -2, and 0 under 4. The product, if it's a ratio, then I may have undefined. But if it's a product, the product will always be 0 when any of the factors is 0. Now, this and this and this, they have the same sign. They come from negative, go to positive. You don't have to plug in numbers unless you want to. You can go ahead. But it's a waste of time. See? See what I did? Okay, but the other one has a negative leading coefficient, so it will look like this. It will come from positive and go negative. And it will go to negative numbers. And now all I need to do is determine the sign. When I determine the sign, I only count the negatives. I don't care about anything else. There are 3 negatives, negative. There are 2 negatives, positive. There is only 1 negative, negative. 2 negatives, positive. 1 negative, negative. So it's negative where? Here, here, and here. Which means this is the solution. So I will write x in the interval, negative infinity, -2 with a bracket, union, bracket at 0, comma 1/2, union, 4 to infinity. This will be difficult unless you want to graph the product and start plugging numbers in between after you find this x-intercept. There are other possibilities.
If this was in a distance travel problem, would that mean there would be 5 parts of the integral?
Yes, but it's not going to be the case.
Okay.
No, because you have to determine the absolute value. So that's a different situation.